Hi, I am Jasper Arturo Chisahagan, and I'm currently an Associate of Aviation Electronics Technology student from Philippine State College of Aeronautics. The topic of this discussion is about pitot static system. Let's start. An aircraft pitot static system comprises a number of sensors which detects pitot pressure and static pressure by the forward motion of the aircraft. These pressures are used on their own or in combination with each other to provide indications of various flight parameters. The three pitot-static instruments are the altimeter, which indicates the altitude of the aircraft, the vertical speed indicator, which indicates the rate of climb or descent, and the airspeed indicator, which indicates the airspeed. Static port is located on the side of an aircraft. Although it depends on the design of the aircraft itself, it receives undisturbed air and leads it to each static instrument. Pitot tube is located beneath the wings and is only connected to airspeed indicator. It has a small hole at the front from which ram air enters and a drain hole at the back so rainwater can pass through it. It also has the capability to be heated to prevent ice from forming inside the tube. Altimeter indicates the altitude of the aircraft, making it one of the most important instruments. It functions by reading the distance above the given pressure level. It consists of a stack of sealed aneroid wafers with an internal pressure of 29.92 inches of mercury. These wafers expand and contract based on the static pressure inside the casing of the altimeter. This static air enters the casing through a tube attached to the static ports of your aircraft. Mechanical linkages connect the movement of these wafers to needles on the interior face of the altimeter. Compression of the wafers translates to a decrease in altitude, while expansion translates to an increase in altitude. The long needle with an inverted triangle at the top indicates 10,000. The short needle indicates 1,000, and the medium length needle indicates 100. This is an accurate method of reading an altitude when the temperature and pressure is constant, but that is not always the case. The Colsman window connected to an adjustment knob helps compensate the non-standard pressure. Turning the knob raises or lowers the pressure scale in order to equalize the outside pressure. It is given by either the ATC or local weather observing system. The vertical speed indicator is a differential static pressure instrument that indicates the rate of climb and descent of the aircraft in terms of feet per minute. The diaphragm is connected directly to the static port and mechanical linkages to the face of the instrument. It is located inside an airtight case which receives static pressure via calibrated leak, which is a tiny hole that restricts the flow of pressure. If the aircraft is in level flight, the VSI indicates zero and the pressure around the diaphragm is also equal with it. When the pilot initiates the climb or descent, the diaphragm will immediately change, but the surrounding pressure changes at its lower rate. The difference of pressure causes the diaphragm to expand or contract, which translates to a climb or descent. For example, if the pilot initiates the descent, the diaphragm pressure will immediately increase, matching the outside pressure. However, the case pressure will increase more slowly. This leads to a higher pressure inside of the diaphragm than its surrounding and causes an expansion, which in turn indicates the descent on the VSI. Keep in mind that there is a lag in the VSI, giving an inaccurate reading and the pressure stabilizes at a delay of roughly 6 to 9 seconds. The initial reading on the VSI is called trend, while the accurate reading is called rate. The airspeed indicator is also a differential pressure instrument, but it is the only instrument that utilizes both pitot tube and static port. The airspeed is measured in nautical miles or knots in short. The ram pressure that enters the pitot tube is the dynamic pressure plus the static pressure. In order to not receive a different airspeeds in different altitude, the static pressure needs to be cancelled out. This is done by connecting the pitot tube directly to the diaphragm, which receives total pressure. The static port connects and fills the case surrounding the diaphragm with static air. This will cancel out the static pressure inside the diaphragm, leaving it with only dynamic pressure. The dynamic pressure causes the diaphragm to expand or contract. It expands as the aircraft flies faster, and contracts when the aircraft flies slower. The mechanical linkages connected to the diaphragm translates the information into airspeed reading on the ASI. Some aircraft have color-coded ASI. The white arc indicates that flaps are allowed to be extended. The green arc indicates for normal operations. The yellow arc indicates limited to fly in smooth air. And lastly, the red mark is for maximum allowed airspeed. That is all for the Pitot Static system. And again, I am Jasper Arturo J. Sahagan of AAET 1-3, and thank you very much.